Okay, thanks again for joining the session. And a little bit disclaimer, I'm going to talk about examples only from my career experience, nothing from what I'm doing today. And I hope that you can learn a lot from my insights. And if you have any questions about patterns, also feel free to ask me in Slack. I may delay my response because I have a lot of things in my list today, but I will reply finally. Promise that I will reply to everyone. Now, if we go back to sessions, we already did refreshing, so let's start directly with state pattern. And I can also go to slideshow, and I can put you here, so just with cameras on, thank you, I can see you. Just one more moment. And okay. And yeah, now I see everyone. Now, state pattern. First of all, this is going to be behavioral one. So little reminder. So when this gang implemented invented patterns, not implemented invented patterns, they actually find 23 the most popular. And then they design it to 3 groups, which is 1 creational, 2nd behavioral, and 3rd structural. So creational patterns today, we can learn a lot how languages implement creation of the object from these patterns. But when we do programming, we actually already use a lot of tools on the level of language. So it's more like for us to go deeper to the level of language, like how language actually progressed, what was evolution of language. And we did session on all creational patterns. For behavioral patterns, it's like when we create the patterns for some behavior from scratch. So they are more interesting, and a lot of them actually apply it on system design. So we can learn like what today's system design patterns could be as idea from these low-level design patterns. And I love this pattern state because it could be applied pretty much to anything when you design your system. So example in book, you can go to book and you can read this example. You can get more ideas about this pattern. They looked at Gumball machine. They looked at states and they thought, how are we going to program this Gumball machine so it will work without human interactions? It will just do the job. So they would use state pattern because it's allowed for objects to either to change its behavior when the internal state changes, because behavior is different, really different, but states are quite the same. And that's how we can abstract a lot of things from each other. If we go to this website, okay, let me see. So let me reshare my screen so I could actually share this instead. It could be easier. Yeah, like this. So when you go to refactoring Guru, you will see that this is also about different states, and basically the problems that they try to picture that when they doing it with different states, this guy doesn't understand what to do with them. Also, state looks like they are not, they may not be linear, and that's made a lot of complexity as well. So you will see there are a lot of interactions with state. This is called finite state machine, and you can Google it and read through Wikipedia what is finite state machine, because it's actually was evolution programming when they come to the idea of this machine, because that's allow you to formalize what exactly going to happen. Example is documents. You have documents that have basically draft, moderation, published. If you ever use Confluence as a documentation document-oriented system, you may see that you first can create draft, and then you can say now it's in moderation, everyone could do this, and then it's published, and you can actually fix this page so no one can change it as well. So this is very simple example of state, and you see like different states could be very different by like how exactly you work with them. Yeah, so if we do it straightforward, we would describe what is happening in different states. Like state could be draft, and the next state could be moderation, etc. And we already talked about creation of objects, and something I was telling that I think is important when you create an object and when you manage your object, which is your business object, which is something you're trying to give to the world. So basically, when you have method like publish, it's important to be as a part of data class that you create or data object, because here you can say, so sorry, here you can say if it's possible to put object in this state. So basically, you can't publish state if a role is not admin, for example, in this case, yeah. Or you can't publish if it was draft. If it was draft, in this example, it just got to moderation, but you may do like programming error. Like I can't publish something that's a draft because it should be in moderation first, for example. And if it's already published, like, okay, there was concurrency in execution of the program, and it's going to change state to publish, but it's already published, so I'm not going to do anything. This is an example of this idea. Yeah. So basically, the pattern, what pattern actually say, let's do it as an interface state. And in this interface, we will say that we're going to render, publish, etc. And then each state will be implementation of this. And now, important disclosure, I've never used it in this way, like this pattern is saying to do this, because it's like actually feels overwhelming to do like for state exact classify and describe behavior there. It's very late data-oriented programming, but pattern like this, it's indeed exist. And I think interesting lesson from this, it's not necessary for this classic pattern to be used and to be applicable for modern programming at all, because I would say like, okay, no one is doing it like this. However, like no one did it in exactly in this class diagram. Really, no one. I've never seen it before. If you've seen it, please correct me right now. Otherwise, it will be forever documented at this recording. So this suggests that you do concrete states. And if we go back to our presentation, I can say that I feel like state is an important concept, not this pattern, not exactly these design patterns, but exactly the concept of state where you describe what's going to happen. If I would rewrite this book, I would put there a enum, which has state locked, play ready, and that's it. And then when I create, I don't know, internal static class player, I can say that on log, every time we mandatory need to check what state it is. And exactly this idea to basically check state every time before you do any action with model. This one can save you a lot from production issues. That can save you a lot of time of debugging and trying to understand what exactly happened with model, why it's end up something to do that it's not meant to do, because it was like someone tried to do it in wrong state of the module. to think about something that's completed. Like we publish document, we think it's published, so it's the end of the document, but someone trying to edit it, and there was no checks for state. And that's why we had an error. Someone could change documents that's published while we thought that if it's published, if it's further there, and there is bugs and send emails to this system that gives documents to publish because we are very unhappy. So from this pattern, this is something I would get away. I had to get away actually when I worked with it. And I've learned it very well. Like you actually can save a lot of time and yours when you use these states like this. When you basically start design your system, your product is defining what state is it and what's possible to do with object in this state and what's not possible to do with object in this state. That gives you much cleaner design. And it's not even that important if it's low-level design or it's a system design, because you basically would think about your products as finite state machine. This is something I would like everyone to learn if you never ever heard about them. Now, a bit more interactions. Have you ever used state? Have you ever heard about finite state machines? Could you share your thoughts? Could you raise your hands if you work with states like this? Okay, yeah, we have few hands. Yeah, thank you. Good. So, okay, this is diagram again explained finite state machine. That sounds crazy, it's a finite state machine, but it's nothing super complex under the hood. It's just the way that we describe everything as a state, and we need to also trace what state it's going to, and that it's what state it's end up. Thank you. So I mentioned today chatbot. So think about that you creating chatbot or like even messenger and you have messages. So think about it. You track every message in your messenger, in chatbots. Chatbots could be done already in messenger. So we can think step back exactly about messengers. So we create a state and message could be sent, could be seen. If you look at current messages, they are so smart. They share with you. It was sent. It was read, and then you can also allow them to change messages. And now almost every messengers give this function. Like you can change it for like if it was sent like I don't know 2 hours, no more than 2 hours ago. But after sometimes you already can't change it. So that's more complicated, but you understand. And if it's changed, it's also give you, if someone you talk is already read, this one has been changed, and if they read it. So I feel like it's smart, and this is important that you may also delete these messages, and that's your state machine. You basically track this message, what happened with this message, and show every message to user with this state machine. And even like you send a lot of messages and messengers, but when you design things like this, you think about like every message is very, very important. So people could, I don't know, pay for business subscription for messengers. And that's why you like treat it as that. I don't know, it's the most important thing that's happening in Messenger, just the message. Okay. So, and as example, product. So I think now it's clear that when you do delivery from any favorite marketplace, you can think that your item was first paid and painting, then shipped, then delivered, and you also like when you design your own marketplace, you may send SMS or emails or everything every time when item actually change the state. That's it. Right now I have, I don't know, tons of emails about my orders in marketplace. We already talked in some sessions about Saga pattern and choreography, so that's also about changing state, but on a bigger level, so we can have few microservices. If we're talking about sending messages, we will have another microservice that's going to send messages, notifications. You may remember it from strategy pattern where we said that we will have like, I don't know, Slack, SMS, and emails, and I don't know, posts for sending notification. And we do all this by having the item and having all the states. When we know that item changed the state, we send a message, and then we go to item service and then just get all details about this item, so we can reach our message with all details about this item. So this is another example where would you use state pattern as well. Now I already asked you if you've seen this one. Isn't it creation of pattern concept? I think that's it. Exactly, that's it. So it's for me like more creational pattern, not behavior one. And because also I would use it not as diagram class that they suggest in this book. I wouldn't do like objects for every state. Okay, proxy pattern. This one is structural, and to understand the order, I just follow the order from the book. That's why I think it's not like all behaviors in one. It's behavioral, structural is the ones that they give in the book. And also the order they give in the book, they say like it's from the most popular to the least popular. However, for me, it's kind of, I would argue as well how they define which one is popular, which one is not. So for proxy pattern, the idea is structural patterns that we need common structure, all the same, and that's why we use pattern to do these structures. And let's look what was example in the book. Oh, there is a question. Yeah. No. Okay. Let's look at the examples book. We have a CEO who basically asked us to do gumball machine, and now they want to monitor them remotely, and they have networks in place for monitoring. Now, how we would do monitoring for this gumball machine? We're going to use proxy patterns because it gives us something like placeholder for object to control access to this. Let's go. Okay, let's share what refactoring patterns Go is saying. So when we have a lot of things that come into database, you may have a problem because database couldn't cope with all these requests. And the solution of this to put proxy that's going to protect database from all requests. This is basically just design patterns. And let's look at design. So here is B can do, so even we know that it's very popular to be system design pattern, we also can protect our software on low-level design, which is mean implement our own proxy class. And in this case, we have service that's going to be invoked, that we create it as an interface. And we protect real service from invocation through proxy class. So we have real service, and then we do operations. But what is important that in proxy one, we also have check and access. Or we could have rate limiter. When I said that we can DDoS quickly database, which is mean giving too many requests to database, we can basically protect it by having proxy and check like how many requests were done like in last 5 minutes. Yeah, so that's what proxy will do. They're going to protect real services, real microservices, real classes that's responsible for something. Now, I like this one. If we think about different proxies, we also can see that there is firewall proxy, caching proxy, the one that also can protect from too many queries. And we also talked about caches in strategy pattern. So you may remember this one, you may cache, and we also talking about caches when we talked about wrappers, which were decorator pattern. And smart reference proxies, that's additional actions when subject referenced. For example, number of reference for the object, which could be rate limiter as well. So I would say rate limiter proxy today. Okay, cache loader. If you would want to do this in Java, that's my favorite library, Caffeine. That's straightforward. For Python, you will use something different, like you may create last recent usage cache, and then you will use this one to basically check how many times spent from one to another one. That's how you will use this pattern, like to protect the system from too many queries. By the way, I mentioned last recent usage cache. Everyone is familiar with this type of cache, or should I then give a link to explain it later as well? Just let me know. Raise your hand if you are familiar with these caches. Okay, I need to explain. So last recent usage cache, which means that we basically build the cache on the rule that we would save everything that recently were used, and we're going to, if we see that this object haven't been used for too long, then we're going to remove it from cache. That's the idea. So cache store everything that were used in last, I don't know, 5 minutes or in last 20 minutes, 30 minutes, however big cache we can maintain and however like our users active, like depends on this, but that's the idea about last recent usage cache. Yeah, and I will put link in our Slack channel, which is design patterns, to explain this cache as well. Thank you for letting me know. Now, if you go to system design examples, as I said, load balancer is very good for being a very good proxy. Reverse, it's called also reverse proxy in this case. And I hope I hope it doesn't sound too bad because we have proxy, we have reverse proxy. So reverse proxy here is load balancer because it's not only proxying queries, it's also can route it to different applications. That's how I can understand reverse proxy. Like, why couldn't you just say proxy? Because proxy just gives the access, but reverse proxy also can change the destination, depends which one is ready today. Yeah. Anyone? Yeah, there is a question from Alina.
Hi, I have maybe a dumb question, but you can use also proxy on the cloud provider, and I was wondering if you can justify more in the scope of when you are using this. like because you can use it on the cloud.
Exactly. So proxy, I feel like today it's pattern that's again became system design pattern, not like low-level design pattern. You still may do like caches to protect twice your application, but indeed you would very commonly use proxies in cloud. Oh, there is another topic about cloud proxies, to be honest, and your question is not dumb at all. Like it's very good question. And if you read the book, it say like there is no dumb question. um, so today there are many different ideas of different proxies that you could put in cloud. The one that's coming to my mind as the first one is Istio proxy. I don't know if anyone heard about it. Service mesh things. So these things implemented to live like close into your application and containers. Like you basically spin pod in cloud, and then in this pod there will be two containers. The one will be container with your application and another one with Istio proxy. That's just called sidecar. And I feel like I give a lot of terms that I need to explain every of them for another session. But in short, I don't know, short answer, yes, you can use cloud proxies, and it's what everyone is using today. It's a lot of ways to use cloud proxies. Or, for example, as a first ever point to your application could be Cloudflare proxy, very popular proxy to your system even. Sorry, do you want to say something else?
No, my son was coming, so
Okay,
I
good.
was like, go.
Yeah, good. So Cloudflare, if you heard about Cloudflares, they give proxies that basically protect the whole system. And if you remember about facade pattern we talked last time, like facade is your API gateway. But even before this, you will put Cloudflare, so you can make sure that no one would come into the whole system with unauthorized access. And then you can design a lot of security things, like how exactly you would exchange with clients, secure connections, secure certificates, etc. This is something that Cloudflare can do. Again, rate limiters, etc. So you would put it even, proxy will go even before your facade. That's how you can think about it in cloud. And then after facade, we're like API gateways. Before every single application that's going to respond with data to your client, you also can put proxy. And there are like few ways how to put it in cloud. It could be like, as here, it could be load balancer. It could be in drinks. It could be something that technology service mesh, where you put them together in one pod, then you already use Kubernetes or something else. Yeah, so that's how you would do. So basically, you almost everywhere put it on the design system level. And these classes and these coding examples, it's kind of how you could also double protect your application. Even you put these proxies already, you can also do something even more smart inside your applications. And it's a very good question, because you can also think about trade-offs. For example, I put you the example with caffeine library cache, that you could use distributed cache, and you can spin up another service that holds this distributed cache. For example, Hazelcast. This is first ever coming to my mind as popular distributed cache. But what is the cost of this? That instead of writing it quickly inside your application, you need to do all these infrastructural things to put this cache. And if machine that hold this hazelcast cache will fail. That's the cost that you will pay to debug, to try to understand why it's failed, etc., rather than just having it as a library and building a new application and just quickly code this caching inside the application. That will be your trade-off. Like, yes, you don't have to code it by yourself. You don't have to plug the library. You just put cache as distributed cache. And you also can render with, you kind of distribute data between services, which is cool, but maybe you don't need these complex things at this level. Maybe it's enough to have cache inside the application. In this case, like maybe it will be easier for you just to write a few lines of code and do not think about infrastructure at all. Did I make it easier?
Yeah, I'm sorry because it's a long, we can stay more and discuss, and I don't want to distract attention from our lecture.
It's a good question anyway. I think proxies is powerful thing today if you think about high level design. And I just showed you like what was a prototype of this one, and you still can just implement it with coding. But today it's very popular to use some already implemented service to balance all this, but deal with infrastructure, deal with like how exactly you would tell Nginx to handle connection in this and in this way. Yeah. Okay, I hope now it's a bit easier. But yeah, now you think that now you realize that proxies you may met them everywhere in your life. I think because it's just 12 minutes before 8, I would stop on this. I wouldn't go to another presentation like we did last time. So basically, that means I opened for more questions for today's sessions. So we discussed a lot of things. We started with strategy. We discussed decorator, and in decorator, we also discussed how we can, by coding, do a lot of things like caching queries. It could be part of decoration of request and response of this layer to accept request and response, authorization, caching. What else? Authorization, then authentication. All of this could be done through the creator pattern as well. However, it's very popular to do this proxy pattern as well, and that means just put service that's responsible for all this authentication, another one for rate limiting, like how many requests per hour per 5 minutes I can accept, to basically load balance. Then you can put it as infrastructural components. And today you can find a lot of frameworks that's already powerful to do a lot of things on the same service. We discussed, I already covered what we discussed last session, and we discussed all creational patterns. So, any questions so far to this content, to me? Okay, I'm going to stop recording. And